Welcome to Project 2.7.4, Laser Cat Toy. This is the cat toy working. This movement is created by connecting two servos together in a pan-tilt connection, being controlled by 1 nano.
The servos run off of pulse width modulation, or PWM. There's a method where we send quick electrical pulses to control the position of servo motors. In this project, the move servo function sends a high pulse lasting between 1000 and 2000 microseconds. The pulse width tells the servo where to move, and each cycle is 20 milliseconds in length. For example, if it is high for 1 millisecond, then it will be at 0 degrees. If it's high for 2 milliseconds, then it will be at 180 degrees. If it's at high for 1.5 milliseconds, then it will be at 90 degrees.
There are two modes for this toy. One where it will move by itself, and one where it can be controlled by a joystick. To switch between these modes, you press the joystick button and it activates an interrupt. To allow this to move the servos simultaneously using a nano without the library, I have used the delay microseconds to allow the nano to switch between sending out the PWM for the servos, while the other PWM is holding a high or a low. This way they are moving so close to one another that they are appearing as if they are moving at the same time. This is the code. This part of the code is the interrupt. This is used because we always want the mode to change when we press the button. So when there's a falling edge detected, then the function toggle mode is called, which changes if random mode is true or false. And depending on that, the ternary operator in the loop function will run either joystick control or random movement. In the random movement function, the first step is creating a random seed. Then a random amount of time, 0.5 seconds to 2 seconds, is chosen to be the time between the servos moving. The next step is to check if the interval needed has elapsed by using millis. Following that, a random number from 1000 to 2000 is generated. This will serve as the amount of time that the PWM will be high. The values for that pin and the high time are mapped to the move servo function at the end. The move servo function first stores the pin and high time given by random movement and joystick control to the variable pin and pulse width. Then the first servo receives a high signal for the pulse width. While that is happening, the other servo is set high for the value of the other pulse width. When pulse width has elapsed, then the servos receive low for the remaining 20 milliseconds in the cycle. Thank you for watching.